Hello. Before we start today's lesson, I just want to give a shout out to all of the amazing Questonians in 7th grade. You're my favorite. If you're watching this, you are my favorite. Please remember that you need to be filling out this part as well. So your name, Math 8, and whatever the date is. And then today's lesson is on adding and subtracting fractions and decimals. Fractions and decimals. But remember, we are doing positive and negative. All right, so the first part, hopefully you remember the decimals unit from 6th grade. When we add or subtract decimals, we need to remember to line up the decimals. So these are both simple problems. I'm actually going to change this one to a negative, okay? So make that change. And I'm going to change this one to a negative. All right, so remember when we are working with positive and negative numbers, we have to first scan. It's an addition problem, so we both have to scan, and we have unlike signs, so we're actually going to subtract. So we're going to put the bigger absolute value number on the top, and we're going to line up the decimals. And because they're unlike signs, we're going to subtract. And we are going to put our 0 placeholder and then subtract going down. 2 minus 0 is 2. 9 minus 3 is 6. Bring down that decimal. 8 minus 2 is 6. So that's our answer. Remember, with subtraction, we need to add the opposite. So keep, change, change. So now we have like signs, so we line up the decimals and add in our 0 placeholder, and we're adding them. 4 plus 7 is 11, carry the 1, bring down the decimal, 6 and 1. And since they were both negative, your answer is going to be negative. All right. When adding or subtracting fractions, however, we need to have a common denominator. So that bottom number has to be the same. So the adding and subtracting rules still apply. So here is an addition problem, unlike signs. So we know we're going to subtract, but we have this is a 4 and this is an 8. So we need to change so they both have that like denominator. 4 goes into 8, so we can actually change this to 8s. 4 times 2 is 8. 1 times 2 is 2. So now we have negative 7/8 plus 2/8. And we know that our common denominator is going to stay the same. So all we have to do is really focus on the top. Negative 7 plus 2. Unlike signs, we subtract. Oops, I should change that back to purple. Unlike signs, we subtract and take the sign of the greater. There are more negatives, so it's going to be negative. Again, if you need to draw out a picture, it would look 1, 2, 3, 4, 5, 6, 7, and 2 positives, and opposites attract, so I'm left with negative 5. For this next problem, it seems a little tricky because the 3 doesn't have a denominator. So we have to change it into a number that has a denominator. So any whole number over 1 is the way we write that as a fraction. And we need a denominator of 2. So 1 times 2 is 2. So we have to multiply this top by 2. So now I have 6 halves. So 6 halves plus a negative 7 halves. So I know my answer is going to be something with 2 as the denominator. So I have to just look at that top. They're unlike signs. Unlike signs. With unlike signs, you subtract. So 7 minus 6 is 1. And there's more negatives. So your answer is going to be negative. All right, for these problems, we have to change both of them. And there's one that's a mixed number. So if we're adding and subtracting many times, it's easier to work with them if they are improper fractions. So I'm first going to change this to an improper fraction. 5 times 1 is 5 plus 1. So now I have a negative 6 fifths plus 3, negative 3 fourths. So now we need our common denominator. The first number that both of them go into evenly is 20. So now I have to think, 5 times what gets me 20? So 5 times 4 gets me 20. So I have to do the same to the top. So now I have a negative 24. And for negative 3/4, 4 times 5 is 20. So I have to multiply the top by the same. So 3 times 5 is 15. So now I have negative 24 twentieths plus negative 15 twentieths. So we're going to look at just that top part because we know our bottom number is going to be 20. I'm going to scan the problem. They're like signs, so I know I'm going to add. So off to the side, I'm just going to do 24 plus 15. That gives me 39. So now I have a negative 39 twentieths. So make sure you don't drop that negative. So that gets me 20 goes into 39 one time with 19 left over. I'd like you to pause the video and try to do this one on your own and then come back to check. All right, so I came up with negative 1 and 14/15. I did this one a little different because the denominators were big and I didn't want to do that multiplication. The way I did this is I first changed to my common denominator of 15. So 3 times 5 is 15, 4 times 3 is 15, so I did the same to my numerators to get this new thing, this new problem. It was a positive and a negative, so I knew I was going to subtract, so I set it up like this. At this point, we could have changed them to improper, but like I said, I didn't want to have to do that multiplication. So what I did was I changed this 6 wholes to 5 wholes, and then I took one of the wholes and broke it to 15/15. 15/15 is the same as 1. So here is my 6, and then here's my 5/15. So I added these two together to get my 20/15. Again, fraction work is 4th and 5th grade topics. The only thing we're doing is adding in the fact we're working with negatives. So now, unlike signs, I'm going to subtract. So 5 times 4 is 1. 20/15 minus 6/15 is 14/15. We had more negatives, so it's going to be negative. That was a tricky one. Again, fraction work is past units, past years, so I'm hoping you remember how to work with fractions. The only difference is now we have these negatives to worry about. So anytime you have a subtraction, you need to remember you're changing it to adding the opposite. So keep, change, change. And then you have to change to like denominators and do that fraction work. So keep, change, change, and do that fraction work. I want you to pause the video and see if you can change them to like denominators and get those answers for me. Okay, so I'm going to start with the second one just because it's easier. Once we changed it, they're like signs, so I know I was going to add. And it's easier to change to like denominators because 3 goes into 9. So I multiplied both the top and the bottom by 3 to get my new fraction. And then like signs we add. So 3 and 3/9 plus 5/9. 3 plus 5 is 8. Keep my denominator and bring the 3 down. And since both were negative, my answer is going to be negative. This one, like the last problem, was a little tricky because once we changed it, we were going to subtract. So I changed them to like denominators, and then I set up my subtraction problem. But because this 3, and I'm subtracting, this 3 is less than 14, we needed to change it to a number where the denominator was greater than 14. So I changed my -4, or my 4, to 3 and 1 whole. So I changed that 1 whole. So 3 plus 1 is 4, but I changed that 1 to 21 over 21. So this means the same thing as this, but now we have our denominator. So we borrowed 1 from here so we could have a bigger numerator. So 24 minus 14 is 10, and then 3 minus nothing is 3. My denominator stayed the same, and this was negative. All right, again, that's pretty tricky, but you have to remember like denominators and use those integer rules. Peace out.